In this video we'll look at the electrophilic addition mechanism for alkenes reacting with steam to form alcohols. This is a very important industrial process where ethene is reacted with steam with a phosphoric acid catalyst at 300 degrees C to form ethanol. However, any alkene can react with steam with the phosphoric acid catalyst at a 300 degrees C-ish to form an alcohol. This isn't specified as a mechanism or a reaction that you need to explicitly know in the organic chemistry section of AQA. However, I think it's a very important one, so you may as well watch it. I'll go for propene again, just because I like an asymmetric alkene. So propene, 3 carbons, it's asymmetric. We know that the high electron density of the double bond, particularly the pi bond, will attract electrophiles. Electrophiles tend to have a partial or a full positive charge so that they can accept a pair of electrons. Water, we know, is a polar molecule. I've only drawn one of the polar bonds because that's all I really care about in this mechanism right now. As this electrophile comes along, it could form a bond for the hydrogen. The delta positive hydrogen could get attached in the first step of the mechanism to the carbon on the end or the carbon in the middle. If it gets attached to the carbon on the end, I will form a primary carbocation, which is less stable than if I form a secondary carbocation. So I'm going to draw my water molecule in the most appropriate place for me to show the bonds that I want to show forming. If I add my partial charges to negative that are relevant, and then I have a pair of electrons coming out to form a bond between the carbon and that hydrogen, that makes the pair of electrons on the hydrogen-oxygen bond go onto the oxygen. That produces my very stable, or more stable at least, more stable than a primary carbocation. I've now attached that hydrogen here, and I have an OH minus and a lone pair of electrons on my oxygen, and I have my very stable secondary carbocation that is being stabilized by the electron pushing alkyl groups in the positive induction effect. Next, lone pair of electrons will form a bond to that carbocation, forming my major product, which is bond to the oxygen, hydrogen, hydrogen. Obviously, if you were asked for full displayed formula, you should draw the OH bond, so be careful. But there you are, I've made propan-2-ol as my major product. When this is a reaction used to produce ethanol, for example, H2O, so ethene reacting with steam or water to form ethanol, this is a very good reaction compared to fermentation of glucose because you just make ethanol. You make 100% ethanol. You make a pure product with 100% atom economy. It is pretty good. Whereas fermentation, you have to then distill, etc., etc., etc. However, where does the ethene come from? Ethene tends to come from the cracking of crude oil. Crude oil is a limited resource. Cracking has is very energy, has high energy demands. There are pros and cons to both. Obviously, glucose production takes land, is weather dependent as well. there are pros and cons to making ethanol via this reaction or via fermentation of glucose.